Okay, so the first two questions, multiple choice. So let me paint you a picture of what's going to happen on the last two problems. And this is what we're actually going to do tomorrow. So we're going to assume that that marble launcher launches at 8 meters per second. So we're here, we're going to launch a marble, okay? And the launch velocity is 8 meters per second. And we're going to launch that thing at 45 degrees. So these tables, and that's what we're going to use, these tables are 0.7 meters tall. And what I'm going to do is I'm going to put a target on the table 1 meter from the edge. So we're going to take a plastic cup and we're going to try and launch this thing where it lands into the cup. That's 1 meter from the edge of the table. So what I want you to do, and this is what you're trying to figure out, is how far from the edge of the table do I have to set that marble launcher so that it lands and hits the target 1 meter from the edge of the table. Now clearly, what does your maximum height have to be greater than?
0.7.
Yeah, 0.7. Because if my maximum height isn't above 0.7, guess what?
It's not gonna get in.
It's not going to hit it because it would never get above that point. So there's a couple of different ways you can work this problem, but understand that it's on the way down, because if you think about it, there's actually 2 times when that marble would be a height of 0.7. It's going to hit a height of 0.7 on the way up. It's going to hit a height of 0.7 on the way down. Okay? You want to obviously look at it on the way down. So what you're going to try and do is say, okay, based upon this information, I'm going to put that marble launcher at a certain distance away. We're going to launch it, and then we're going to see what's going to happen.
So are we finding range?
I'm just telling you. That's
So I
up
think
to
we're
you.
finding range.
When you get to that second problem on the back side, okay? So you have a wall that's 7.5 meters tall, okay? That's your height. So the ball, when it clears the wall, okay? So here's the baseball. So you've got a radar gun, and you're reading the speed of the ball. The speed of the ball is 36.0 meters per second, okay? That's the resultant of your X and Y components, okay? That's 36 meters per second. You're told that it's an angle of 28 degrees with the horizontal as it clears the wall. So this angle in here is 28 degrees. So your vector is 36 meters per second. That's a 28 degree angle. So what you want to do is work backwards and figure out what was the launch velocity of the ball so that it clears the wall. So obviously you're going to have to find your Vx, and you're going to have to find your Vy here, and then find that result. Now, let me give you a hint. If you know the Vx when it clears the wall, what else do you know?
The initial angle.
No, you also know that Vx, that it was launched at, because you're assuming that your Vx is
Yeah.
the same. So if you can find your Vx at any point, you know your Vx at every point, okay? So, let me give you a hint. Is this going to have a Vy component when it clears the wall? So the ball's coming down like this. Is it going to have a vertical component
Yeah.
to its velocity?
Yeah.
Yeah.
When it lands, is it also going to have a vertical component to its velocity?
Yes.
Yes.
So when it if you could find the vertical component here when it lands, what else do you know?
When it starts.
The vertical component when it was launched.
Oh.
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 Now, hold on. But wait, there's more. You can find that vertical component. I'm going to make up a number. Let's say it's 18 meters per second. I'm just making up a number. Let's say it's 18. Okay? if this is 18, when it lands, is that velocity when it lands gonna be bigger or smaller than 18?
Bigger.
Bigger. So you know the vertical velocity when it lands has to be bigger than what it is when it's 7.5 meters above the ground.
Yes.
True?
So you're
Do you know that equation?
Yeah.
Do you know, you're gonna know the initial vertical velocity when it hits the wall. It's not 0, okay?
Hits the wall, the ball's.
Or when it clears the wall.
Up.
So you're gonna know initial vertical velocity. What else are you gonna know? Distance
Acceleration.
and acceleration. Have I mentioned anything about time?
No.
So what can you use to find the velocity when it lands?
That
That
equals.
equation.
So if you know the velocity here, you know the velocity there. Just saying. Okay, I'm done right now. Stop you under camera.